Hey again, everybody. This is the Math Excel video on 1.1 day 2. And again, on these you don't have to write them. This is just a tutorial video on how to work the problems. So on 1.1.11 it says given f of x equal 18x plus 14, and it says find f of 6. So basically on this problem you're going to substitute 6 in for x. Now of course you don't make it 186, you'd say 18 times x, so 18 times 6 plus 14, and then you get 122. So you could just do the math on the calculator like normal. 18 times 6 plus 14, enter, and you get 122. Or just as a reminder, because we're going to be dealing with functions quite a bit, you go doc, new document, add graph, and this is where you could type 18x plus 14, enter. And then you go to your table by doing Control T for table, and then you can scroll down to where number 6 is and you see 122. So for this problem you probably didn't have to use that feature of your calculator, but it's still good to know, because sometimes it'd be easier to do it this way if you have to get more than one value. Okay, the next one says g of x equal 2x squared, and it says write the domain in set notation. So the graph you're given is 2x squared, which is like that. So just comparing them, the graph of x squared looks like this, and of 2x squared like this. It's a parabola from a quadratic equation, and it's just a little bit skinnier or more narrow because of the coefficient. If the coefficient's bigger than 1, then it's skinnier. But if all we're talking about is domain, there's no issues with the domain. It could be any real number. So even though you may just look at it and say, well, it's going from like -2 to 2, if you change your window you would see that it keeps on going. So now change it to 100 and then you can see it's wider. Later on we'll study functions that have things like vertical asymptotes and functions with holes in the graph. But for something like this, I can't even pick a single point where it's not defined. So it's not that it's bigger than or equal to, greater than or equal to, or less than or equal to anything. It's that it's a real number. So the way they write it is the set of all x's such that x is a real number. And then you need the range. So remember, domain relates to x, range relates to y. So you can't have any negative values for y, so you can't rule out, you can't use the real number or the less than or equal to. It's basically y has to be bigger than or equal to 0. So that basically means from the x-axis to the top. So that's your range. Okay, and then the next one is extra practice A, and I'm just going to start labeling that EP for extra practice. It says list the domain and the range of the relation. So this is a particular relation. It's not a function from seeing that 2 is listed twice for x, and it goes to -3 this time and it goes to 3 this time. So your domain would be 2, 6, and 0, because this 6 is already listed and the 2 is already listed. So you don't have to list your numbers twice. And then for your range, it's going to be your y values, -3, 6, -3, which was already listed, 1, and 3. So that's basically that problem. And now you have a problem that says find the domain and range and determine whether it's a function. So the domain on this, like we said before, is all real numbers. And when it's all real numbers, the inequality notation is this. -infinity less than x less than infinity. The interval would be -infinity, infinity with parentheses. So there's going to be different ways you say it, just depending on the wording of the question. In this one, they wanted the inequality notation, where x is between -infinity and infinity. And then for the range for this one is from -3 to the top. And so -3 less than or equal to y less than infinity. And that is equivalent to y greater than or equal to -3. But they have a two-sided boundary instead of a one-sided boundary. And this relation is a function because it passes the vertical line test. There's not a single place where it hits two y values. And then for extra practice C, the volume of a sphere is a function of its radius, v equal 4/3 pi r cubed. Evaluate for the volume of a volleyball with radius 10.2 centimeters. And in the problem it says the volume is blank centimeters cubed, round to the 10th. So basically you do 4/3 pi times 10.2 to the third power. Just as a reminder about where the pi button is, 4/3 times, the pi button is right there. It's to the left of the H. Pi times 10.2 up arrow 3. And you get 4445.177. And it says round to the 10th, and so you need 0.2. And the other thing to pay attention to is the radius was a distance, so that's in centimeters. And the volume has to be in cubic centimeters then. So if this is centimeters for a length, then the volume would be in cubic centimeters. Alright, that's all for this video. Have a good one.